Welcome to this explainer. Look, if you're managing capital or tracking industrial transitions right now, you already know the deal. Hard to abate sectors are the absolute final frontier of global decarbonization. And today, we're zeroing in on one of the biggest, the global cement sector. We're going to map out the existential threats it faces, but more importantly, the massive blue ocean technological opportunities waiting to be captured. Over the next few minutes, our goal is to arm you with a rock-solid investment thesis on exactly how this industry is going to transform and where the smart money is already moving. Okay, let's kick things off with a number that should really grab your attention: 50%. Global cement demand is projected to grow 50% by 2050. I mean, just let that sink in for a second. Think about all the megacities, the bridges, the endless infrastructure and housing that humanity needs to build over the next couple of decades. This is absolutely not a sunset industry that we're trying to slowly wind down. It's a foundational pillar of global development. It's expanding rapidly. But it's also an industry facing unprecedented operational and regulatory pressure, which makes it perfectly ripe for disruption. So here's our game plan for today. We're going to cover 1. The margin squeeze. 2. The core carbon problem. 3. Near-term tech inefficiency. 4. Long-term bets, specifically CCS. 5. Alternative chemistries and fuels. And finally, 6. The investor playbook. Let's jump right into part 1, the margin squeeze. Let's forget about 2050 for just a second and talk about the immediate financial pain points cement producers are dealing with right now. The real crux of the issue is the cost breakdown. If you look at a typical cement manufacturer, a massive 50 to 52% of their total production costs are entirely tied up in power, fuel, and freight. You're talking about colossal kilns that burn nonstop, plus fleets of heavy trucks moving the product around the world. So more than half of a producer's cost base is completely exposed to the volatility of global energy and transport markets. In an era where supply chains are unpredictable and geopolitical tides shift daily, that is just a massive vulnerability to a company's bottom line. To really put that exposure into perspective, remember early 2026, we saw global pet coke prices spike to around $160 a metric ton. And frankly, whenever coal prices breach that $100 per metric ton mark, the industry faces some incredibly severe margin contraction. What this proves to investors is super critical. Decarbonization and energy efficiency, they aren't just feel-good green mandates to make regulators happy anymore. They are an absolute operational necessity. You have to do this to shield your profits from crippling fuel supply shocks. Which brings us to part 2, the core carbon problem. This is the big environmental hurdle that's throwing the long-term viability of these highly exposed assets into question. You might already know this, but the cement industry alone accounts for roughly 6 to 7% of total global greenhouse gas emissions. To put that scale into your head, if the global cement industry were its own country, it'd literally be the third largest emitter on Earth, sitting right behind China and the US. But the reason this sector is so notoriously hard to abate isn't just about the sheer volume of dirty fuel they burn. The real kicker here is a process called calcination. During clinker production, they heat limestone in a kiln, and a chemical reaction occurs that literally strips carbon dioxide right out of the rock. This one unavoidable chemical reaction is responsible for up to 60% of the industry's direct carbon emissions. So you can't just slap some solar panels on the roof of a cement plant and call it a day. The emissions are fundamentally chemically baked into the manufacturing process itself. Now, I know that sounds pretty bleak, but for an investor, this is exactly where the opportunity lies. Let's move to part 3, near-term tech and efficiency. The good news is there's a really robust suite of readily available retrofits out there right now that provide excellent short-term ROI. Take waste heat recovery systems using organic Rankine cycles, for example. They capture the exhaust heat from the kilns and turn it back into electricity. That can potentially drop indirect emissions by up to 10% and slash electricity needs by a massive 20%. Then you've got upgrades like moving from old ball mills to vertical roller mills, which cuts grinding energy consumption nearly in half. Or swapping out coal for biomass or municipal waste fuels. That can reduce direct emissions by up to 35%. And what's truly interesting here is the commercial viability of these options. We're not talking about futuristic, pie-in-the-sky science fair projects. Upgrading auxiliary equipment or converting to hydraulic drives, these offer really attractive short to medium payback periods. They are highly bankable CapEx deployments that give operators immediate margin relief and a very clear competitive edge right out of the gate. But, of course, efficiency only gets us part of the way there. To solve the whole puzzle, we need to look at part 4, long-term bets, specifically CCS. Let's be brutally honest here, and the industry fully acknowledges this. Without carbon capture and storage, getting the cement sector to net zero is basically impossible. Because of those unavoidable chemical process emissions from calcination we talked about earlier, capturing the carbon straight at the smokestack and storing it deep underground is currently the only viable technological pathway to fully decarbonize traditional cement production. But here's the catch, right? The cement industry basically operates as a regional oligopoly. It's incredibly capital intensive, transport costs are high, and there are very few actual competitors in any given area. So, game theory tells us that in a market like that, firms will naturally delay adopting super expensive tech like CCS because nobody wants to bear that first mover disadvantage. Current modeling actually suggests that if we leave it purely to the free market, adoption could be delayed all the way to 2042. However, if you introduce targeted policy, like a 70% fixed cost subsidy or a time-dependent profit flow subsidy, it completely flips the math. That could bring optimal coordinated adoption forward to 2030. For this investment class, policy timing is absolutely everything. Now, what if we could somehow bypass the calcination problem altogether? That brings us to part 5, alternative chemistries and fuels. Alongside CCS, there is a totally fascinating frontier opening up in material science and advanced thermodynamics. On the thermal side, we're tracking things like the rotodynamic heater, which aims to fully electrify kilns up to 1700 degrees. Now, that's currently at a pretty low technology readiness level, mostly still in the lab or early pilot phase. But if you look at alternative chemistries, things like limestone calcinite clay, or LC3, and bolete calcium sulfoaluminate, these alternative clinkers are rapidly approaching high commercial viability. They offer emission reductions anywhere from 30% to 70% just by altering the fundamental recipe of the cement itself. It's wild. So, how do you time your capital? Mapping this out chronologically gives a really clear roadmap. Phase 1, the next 5 years, is all about funding those highly bankable efficiency retrofits. Phase 2, looking 5 to 10 years out, is where alternative clinker chemistries and circular concrete recycling start grabbing serious market share. And then Phase 3, a decade plus out, is when heavy infrastructure like green hydrogen kilns and full-scale CCS networks really become the dominant industry standard. All right, we've seen the threats and we've seen the tech. Let's bring it all together with part 6, the investor playbook. How does smart money actually clear the roadblocks and unlock these massive returns? Right now, a frankly staggering amount of capital is just sitting on the sidelines because of 4 core barriers. First, there's actually a surprising lack of awareness at the plant level regarding just how good the financial ROI of these retrofits can be. Second, policy incentives are often pretty misaligned or completely lack standardization, which makes green financing tough to access. But the biggest one is high market friction. Builders are hesitant to accept new low-clinker cement blends, largely because old rigid building codes strictly mandate the use of traditional Portland cement. So how do we de-risk this? We need to target markets that are employing specific mitigation strategies. The absolute game changer here is bulk public procurement. When a government steps up and says, hey, we guarantee we'll buy your low-clinker cement for our massive new highway and bridge projects, it instantly de-risks the plant conversion costs for those producers. Plus, making financial incentives conditional on verifiable energy efficiency targets makes sure that capital is actually flowing into real, measurable, on-the-ground upgrades. Which leaves us with this final thought. Remember, global demand for cement is going to surge 50% by 2050. The world absolutely has to build, but we cannot afford the carbon, and producers certainly can't afford the volatile fuel costs. The multi-billion-dollar transition of this hard-to-abate sector isn't just some nice environmental initiative. It's arguably the most overlooked, high-impact investment opportunity of the entire decade. The tech exists right now. The demand is totally locked in. The only real question left is, who's going to finance the clean tech to build it?